So, once again, good morning, everyone. I'll be standing, so my chair will be occupied by our fourth architect. We have a very distinguished panel of structural timber representatives. The group is called Wood or Timber Quality Group. The biggest challenge we are experiencing is really to go about eco-sustainability in the area of living and building, and so using timber for structural purposes, which is a very wide area. Let me just tell you in a few words of what the meaning of this title is. As Luca said, the title of this conference is very meaningful. So, pertinence of technology and sincerity of wood. Wood is the only alive material, raw material that we are familiar with, and it features both positive and negative characteristics as an alive material. So that's why timber poses us meaningful and significant challenges as compared to an inert material. Wood is given to us by forests. So this is the major difference which really determines and drives the different approach to this material, to this raw material. So today's initiative would like to highlight the interactions between a very much fast-paced and sustained technology innovation. We are now living in the digital revolution era. The digital language is controlling technologies that you can all appreciate in these exhibition halls. And how do we combine this with the word project? You here will be our future project makers, project planners, and so the word project implies a lot of different aspects in terms of ethics, aesthetics, and sustainability. So it's a magic combination between these two aspects. So digital planning and design processes, which also has to do with something that is very physical. As we can see, this exhibition is physically present, but we are also digitally present online with all the events that can be attended by whoever is not physically present here. And so with this initiative, I would like to welcome 4 experts of wood as material for building. Let's start with Professor Felice Ragazzo, who is the president of GQL, and he will talk about unexplored territories between mechanics and digital wood in the area of wood applications. Good morning, everyone. I'm very much touched by the presence of such a vast audience that is willing to look at the future, who is so much future-oriented. I've been a professor for many years, ever since 1962. And back in those years, I was only 18 years old. And possibly all of you here in 2 or 3 years will have the same experiences that I had. 60 years have gone by, and I'm still a professor, and I keep on studying. So I asked myself a question about what we do in good terms and what we do well in the area of woodworking technology. There is a lot of good things going on and well done there. However, despite so much innovation that can be appreciated here at Fiera Milano, what is left to be done? What is still to be covered? Or in other words, what is neglected by the industry system? The industrial system and the vast industries such as fashion industry, they all follow market trends Sometimes they are very much linked to how taste develops, and so they make progress and developments in various sectors that are not always the right ones, since many of these sectors consume a lot of raw materials and hurt our environment. So with a few pictures and images here, I will try to show you the yet unexplored territories that a young person may consider and as a nice to explore theme and topic. So let me just open a new window, a new perspective. I have two images here and one abbreviation, wood quality group. Then there is my brand, that kind of flower or butterfly. And just bear in mind, I took this brand, I developed this brand from a geometrical concept which was invented and discovered in the 4th century before Christ by Archita of Taranto in order to solve Delos' problem. There was a plague, priests wanted to build a double altar with a double volume in its structure. And so the project had to establish a side by side, I had to deliver the twice as much as the volume. So I studied the calculation formula, I derived my brand, and the bottom image is a detail of a patent which, together with the architect Fabio Spera and another Roman architect, were able to obtain for structural systems. And Fabio will specifically present this patent in a few minutes. So let me just focus on these 5 key points and elements. Fabio later on will deliver a great and amazing presentation, and then there will be another fascinating presentation delivered by architect Giachino, and finally there is the other side of the moon, that is to say inserts, which will, and that will be a presentation delivered by Mr. Magri. So, when I started to develop my study, my focus was on wood, timber. So wood, timber is a living creature. It has a body, it has a life. It is born, it grows, and it dies out. In order to use timber for building, we don't let wood die. We kill it first to prevent its decay. And this is done in many other fields. We do it with pork, we do it in the food industry, and in many other fields. So I will not investigate further into that. However, in order for me to use timber, I need to become aware and knowledgeable about the physiology of wood, solidity of the building, construction solidity. As my colleague will show later on, I may as well make a construction, I may make a sculpture, but I can also combine several pieces and build a chair, but also a building, a palace. I already told you who I am. I love geometry. I made some publications when I was a small student, when I was a kid at school. My grade in mathematics was very, very low. But then ultimately I developed a passion for geometry and I published books on that. So today I want to focus on geometry in order to fly high. I need to have a deep knowledge of geometry because the geometry helps me thinking better and working better. Of course, we will have to talk about mechanics and digital world, which is the real mesh that each exhibitor here is exhibiting. Our purpose is to go beyond the simple connection and combination of mechanics and digital. Lastly, form is the ultimate aim. A form needs to be considered as the aim of perfection. So pursuing perfection is one of the nicest things that we can do in this world. So let's start from my first point of discussion, physiology of wood. I have projected some odd pictures. The top on the left, there is a fragment of a tree. A tree is born, however, it has its own physiology. Then there are some platan trees in the park where I usually walk, and these trees could be used to produce beams or tables. On the right, there is an object. It's a unique piece. It's made in Ethiopia. I'm not sure whether it's Ethiopia or Eritrea. However, there is a community, the Serramento community, works wood from trees and makes these objects. At the bottom line, I have brought once again two pictures. The one on the left is like a construction made by a natural tree with its branches, whereas on the right, this is a picture taken in Belém at the technology park in Brazil, and you see wood used to make a structure. So wood presents us with different sides, different aspects. We will see it later with the construction examples and with the patent. And we often think of wood looking at the image in the center, but even the straight tree trunk will present us with some geometry problems, because we will have to obtain beams, parallelepiped shapes. I once won a bet with a large company, Missoni, to make a chair. I did not design myself for this chair. To be honest, it was designed. So was able to put pieces of wood together so that this refined and thin and essential minimalist shape could be made with the CNC machines. When the problem was submitted to me, I almost burst out laughing. How come they cannot accomplish this? I can do this, and I will just do it myself very easily. So it would be really a very easy job for me to accomplish. So I went back to Rome after completing my survey, and I had already developed this model. If you look at it on the right side, there is a small trick, a small secret, which is also included in the patent. And the secret is the utilization of CNC machinery, and which exploits geometry which binds mechanical digital, and which are sharp edges free. Finger joints have sharp edges. all kinds of joints are characterized by sharp edges, whereas in this case, I said no. A joint made with sharp edges is not suitable for wood, for timber. I guess you know what anisotropic means, and wood is anisotropic. It simply means that the wood has a prevailing orientation on the one. In one part, it is easily breakable, but in another part, you will have to saw it. And this may represent a problem when you have to join two parts, because it breaks. The wood cells, though, are very, very strong. So if we consider the same volume mass, it is 7 times more resistant than steel, but it's very hard to exploit this strength, this power of wood. So this is the challenge for us. So only a tree is able to exploit this power fully when it grows straight vertically. But whenever you cut a tree and then you break a tree, this power goes lost. And so you have to make very solid and massive logs or beams to support all the efforts. Whereas if you smooth the surfaces and if you soften the surfaces, I was able to find a solution. So I somehow approached the original physiology of wood in nature, which somehow bridges the gap, which is basically the problem of using a material which is spectacular as long as it is a living creature, but once you cut it, it presents us with problems. So it took us very short time to produce that chair. The chair is now sold on the market. I earned good money. I made very nice projects, and this morning the guy from Missoni called me and they told me, we need you to work on Saturday and Sunday when you go back to Rome, because we want to involve you in many other projects. So I will be happy with that. Here we see another type of chair which is very thin, very light, and it sits on tips that are 1 by 1 centimeter big. And we are waiting for this chair to be sold on the market. But with these type of joints allow me to deliver a chair that is super light, similarly to the Joe Ponti's one, but without an inner structure. So it all revolves around the type of joints. So this is to underline how geometry is needed and required. On the right-hand side, you see the spatial space, which Architi used to solve the problem, third root of number 2 in the 3rd century before Christ. He didn't have any computer to calculate that. If he didn't have a computer, he didn't have many tools, and yet he was able, he had a compass only, but he was able to deliver the side of a cube form, which was twice as large. I studied this topic, I developed my own brand, but I also developed a gazebo, as you can see from this picture. And this gazebo project was liked very much, and hopefully it will be made, it will be produced soon. In the bottom part of my slide, there is a sequence of pictures to study joints. There is an incredible and amazing manual by Bartolomeo Saldini, who shows great tables that are with the study of joints, and by working on smooth surfaces, I was able to determine and develop a system of joints that vary in space. So I may cross two pieces the way I like the most, and I obtain the best joint, the best way to join them. So mechanics and digital world, to make a step forward. On the left-hand side, you see the piece of a joint, and the original piece of joint is also depicted in the book by Saldini. It's and it has a very specific name. I obtained smooth surfaces thanks to CNC machines, and I had to change the name of this joint. I called it a joint piece with Juno's curves. So I used a female name instead of a male name, and this is always winning over conventional names. Then I have presented here the picture of some tests, joint tests, and at the bottom you can find the two images of a university dissertation of a young student at the university, which I worked with. He learned how this geometry works, he learned the CNC software, and he developed his thesis at the university on this very topic. And then my last images or pictures, the form, shape as the aim of perception. I was assigned a contract to work on these colors in the church Santa Maria Maddalena in Campo Marzio in Rome, which needs restoration. I'm very excited, but I'm also very nervous about this project. I've already seen this monument. It dates back to the Baroque era, Baroque period, and my understanding, my idea is this. I will apply a very clean, pure geometric rationale, and this is going to be the future of this work of art. This work of art shows us how they would manage the complexity of forms to deliver magnificent results. My issue today is to deliver a magnificent work of art with the CNC machines. So let me show you another example, a guitar. In order to make a guitar, I have my own technique, which is not the standard and stereotyped one. Tools, sitting stools, which I have derived from 14 equations developed in the 15th century to solve third-degree equations. I studied those equations, I designed them, I put a sitting surface, which I obtained through digital design, and I will a sitting stool. Of myself, I am resting on a joint piece, a piece of joint, the so-called Juno's curves joint, and at the very bottom I have my brown brand. Thank you, Professor Felice Ragazzo. This is a professor that is really worth listening to. We should be proud of having him here today. His name is Felice Ragazzo. Felice in Italian means happy, and his surname Ragazzo means boy, young, and he's really still has the spirit of a young, happy boy. And he's been dealing with polyhedric joints for a very, very long time. They wanted me as a woman, as a Juno, to introduce you, and not a man. So jokes aside, I will now carry on with our next speaker, who is also the chairman of Gruppo Qualità Legno, wood quality group. So you can always find updates and information relating to the topics we are discussing on the website www.org, and also through the magazines and journals that I deal with. We have online magazines. We also have a printed version. However, any issue of our magazines can be browsed for free online. So, and we speak about wood from simple wood-made objects to constructions, which is today. So this is and magazines names. We have an audience of future planners, engineers, mechanical operators, that are really eager to listen to you. I'm sorry to interrupt you, but I'd like to share an announcement or a piece of information with the audience. At the new School of Arts, of the Arts and Crafts in San Pietro Fabbrica in Rome. Topics will be plaster, wood and woodworking and masonry. It's going to be a free of charge school, free of charge tuition for 6 months. Accommodation will be free. It's a boarding school. In order to qualify to join this school, to enroll in this school, you need to have completed your diploma program. You need to have excellent grades. There will be a selection process, and the applications must be submitted by October the 30th. If you Google the website of Fabbrica di San Pietro, just search Scuola di Arti e Mestieri, School of the Arts and Crafts, and yes, possibly we will also dedicate some news to this school in our magazines, if you're interested. So let's now go to the directive board of the Gruppo Arti e Mestieri, Gruppo Qualità Legno. So the other distinguished speakers today are really board members of Gruppo Qualità Legno. Our next speaker is Davide Maria Giachino. He's an architect. So the everlasting or eternal dispute between factuality and expressiveness in the construction business, so between knowledge and eloquence in wood-based applications. He is also a professor at the University of Turin, and so he's used to having such a wonderful audience as we have here today.
Thank you. Welcome. It's a pleasure having the opportunity to speak to such a young audience. I actually exerted some violence on myself because in order to avoid talking about wood. So and it would have been all too easy to talk about wood in this context. You heard the headline, quite philosophical. I have extrapolated a few words that I mostly liked. So particularly, I took this image, which is a carved wooden plate by this sculpture, Paul Gustave Louis Christophe Doré, representing King Solomon. King Solomon was very young when he had to rule the people of Israel, but being very young, he does not have the capabilities. And overnight he invoked God. God appears and said, "What do you want?" I'm not able to govern these people, so I want to get wisdom. God is quite surprised. He expected him to want money, power, to subdue other peoples, but he only wanted wisdom and knowledge. So God is happy, so it makes him happy right away. And so I'll also give you intelligence besides wisdom. So he becomes the wisest man on earth. So I wanted to start off with this reflection because at this historical moment, very hard moment that we're going through, we just came out of a pandemic. There's a crazy guy on the other side of Europe threatening us with nuclear war. And so I think we need to stop, all of us, and ask to be gifted with some wisdom. And of course this has nothing to do with this fair, where we're talking about woodworking machinery. But I'm connecting all these to this guy, maybe many of you recognized, great master, Le Corbusier. And before being an architect, actually, he didn't even have a degree in architecture, but he was a humanist, a great man with a 360-degree vision of the world. So this is to say that you don't only need scientific support, technical support, but you also need to have a vision of the world, which is probably even more important. And Le Corbusier understood one thing, his luck, the birth of concrete. We're talking about wood here, but I'm talking about concrete instead. In concrete, you get the stripes of the wood, and it says, but he understood that concrete could be shaped into any form, depending on how to construct your mold. And he immediately had this intuition, realizing these molds with the curvings and the double curves. So this is construction, so you have reinforced concrete stuff here. Imagine this beautiful chimney on the top of the roof of a house. And then this beautiful lady that left us recently, so she's, I mean, we were almost unrecognizable here because we were used to see her with some more years. So Queen Elizabeth, in 1960, maybe nobody knows this, but she came to Turin in 1960. I come from Turin, and in 1960 we were celebrating 100 years of unity of Italy, and a lot of works were realized for that occasion. And Queen Elizabeth gave this wonderful man the gold medal to this guy that maybe you young don't recognize. Those of us who are a bit older. So it's great engineer, Pierre Luigi Nervi. He was loved the world over, and quite neglected in Italy. And by the way, he got a gold medal from Queen Elizabeth, not from our government, from the Italian government. And this extraordinary man with a bond with the story of Le Corbusier, because some works to realize some of his works, Le Corbusier also used engineer Nervi, and he was and in Turing he left us with wonderful you see these folds, these nerve structures, very thin, and I mean you get a shiver down your spine if you think when all this was done in 1960. Today, doing something like this would still be very complex. So the courage of a man who was an engineer and a constructor, so he knew the matter very well from all standpoints. But I have to talk about wood. So I tried to avoid talking about wood, but I have to say something. And going back to the issue of machines, we are at a fairground that represents all this. So machinery is a key component of the development of wood. We wouldn't be able to move forward without these machines. But one day there was this panel that landed on Earth like an ET. So cross-laminated timber, also called XLAM or CLT, but we're talking about cross-laminated timber here. So, and it allowed us to make extraordinary works. This is just a snapshot of what we see around the world. Multi-story buildings. So in the past it was just a few stories, whereas nowadays we even do have skyscrapers done thanks to cross-laminated timber. But we need to make a reflection here as a team here, the Wood Quality Group here, GQL. We're not here to provide you with solutions, but to leave you with some question marks, especially for you, young people, that maybe will be able to develop these question marks into future developments. You see, some of these are coated, I mean, though these buildings are coated in wood, others do have some weird covering. And sometimes it's impossible to understand that these structures are actually made of wood. So the first question mark is, wood is there, but you don't see it. And I mean, in the past we were used to see wood buildings made of wood, but the structure coincided with the shape, like historical buildings, where this was quite evident. Nowadays, there's a total dichotomy about these aspects. I've also been working on some dissertation thesis recently, so a topic that really enthusiasm students, and so I moved a bit forward with this provocation because I came across the restoration of this 800 building. Yeah, you have the plan above, the plan as it was done in the past, done in ink. It was done in red, you know, red, yellow, construction, demolition. Maybe your professors have already explained to you, red is new construction. Whereas below is contemporary building made a few years ago in cross-laminated timber. There's no difference to me. But at those times, we were going around with horses. Nowadays, we have satellites going to the moon. So the rigidity of the system. So Le Corbusier was the master of the free blend. And thanks to reinforced concrete, he opened the way to making open layout buildings. So, but here instead we're going, a step backward, a bit back to the 1800s. And I'm going to leave you ponder on this. We don't have a solution here, but I think it's important to underscore these aspects. We're using technology that is very well represented here at this fairground at an international level, but we're using the technology in first gear, like it was a car. But here, they have not understood the potential of this machinery yet that could really change history standpoint of wooden architecture. So there has been progress, but also a step backwards somehow. Picasso was saying that before creating something new, you have to demolish something else first. You have to clear up everything in order to be able to move on, move forward. So this is my takeaway message. All the more so because this audience here today is all young people we didn't know. And this is my last image. These are my students from last year, first semester, Polytechnical University of Turin. And I always take them round building sites or construction sites. It's always complicated to organize this kind of visits. It's something that it's not required. But I believe it is fundamental to start this relationship between the world of design and the world of where things are done, especially here where we have all this machinery. So it's my wish for you to think about wood and the use of wood in a new and innovative way. Thank you. Thank you to Professor Giachino, stimulating a very important reflection. So back to Le Corbusier free plan, to use this with wood technology. The ribbon window free plan, that's what Le Corbusier did. And this project from the 1800s really is giving us back that step backward he was talking about. There's a projectual designing constraint to subdivide space, the layout of the space, and so you're not free to do what you would like to do. I've been following this group for a number of years, and I'm always surprised, and I'm very honored to present them all here today. The headline was thought of together, so the relevance or pertinence of technology and the sincerity of wood, that, as we said, is the material by excellence because it's renewable and recyclable. There have been some steps forward made, as the patent that architect Spera is going to talk about in a minute. So it's an opening up of our frame of minds. So this drive towards technology, but paradox, we lose sight of design possibilities. So we lose sight of that keyword, design. Whereas with this patent, you see, even to go back to geometric joints that polyedric joints that Professor Ragazzo was saying. So leave the floor to architect Spera.
Thank you, Sonia, for your introduction. Thank you to the audience for being present, and I would like to thank Professor Felice for providing me with this opportunity to present this very demanding piece of work, which we have conducted together in the past few years. we really are very, very satisfied with the extent and the scope of the results achieved. I have decided to describe this work in 5 different steps, plus one. And these 5 steps describe the quality leap that we have accomplished, but also the invention that was then acknowledged by the Italian Office for Patents. So the highlights of our work are the minimum elements as alphabet for composition language, specialized membrane coatings for forms and dimension, smooth joints, wood joints. We often forget about them, but they are thousands of years old and available. Complex geometry and the building formation modeling. So let's start with the minimum elements as the alphabet for our composition language. The approach to prefabrication goes through a minimal set of elements. And this is an approach that it's not new. I will show you in the next pictures. This approach dates back to almost 4,000 years ago. But the novelty of our discovery, of our finding, is that the particular geometric shape and form of these elements was acknowledged. And the geometry that represents these architectural elements, the framework, alpha and beta. Alpha and beta elements are oriented to implement outer walls, whereas astra and gamma on your right are elements meant for inner walls. What's the difference between the two types of elements, the two categories of elements? Well, the difference is that the outer side edge is continuous in one case, whereas in the other case it is interrupted or discontinued. So the difference lies in how you actually orient this element of the framework. As far as gamma rod, another important aspect of gamma and beta rods, they are defined by how two formworks are joined. They must be symmetrical, they must be joined with a dry joining system, no glues. So it is a reversible type of joint and connection. This is one of the important aspects that distinguish this construction system from all the others. Gamma shafts or rods may look simpler, but as a matter of fact, the quantity and the number of gullies is also something that characterizes them. This is the core of the patent. This is the aspect that was recognized as an invention. So we are able to distinguish two types of panels, single-framed panel and double-framed panel. The double-framed panel is made up of two parts. Each of these two parts is made of alpha shafts or rods, and they are connected by means of this type of joints, these wooden pins or pegs, and The shape of these wooden pins is kind of swollen, and it is thinner at the extremity. It is swollen in the central part so that it can absorb better the cutting strength or tensile strength forces. This characteristic is not present in ordinary standard wooden pins. Double-framed panels have an inner part which can accommodate system plants, facilities like exhaust pipes. They are aligned, they are continuous, so this type of panel is very versatile. They can accommodate different types of plants, and it can be, they can be inserted in all directions. And you can also insert insulating panels inside. Same thing applies to single-framed panels. However, single-framed panels are meant for internal inner redistribution. They can also accommodate insulating materials, but also some systems or gabarite materials, which are helpful when you have to install toilet facilities, suspended toilet facilities. And then there are some specific architectonic functions that these panels can perform. So different pitches can be designed for these panels in all directions, not just on the plane directions. Smooth plane junctions or joints. This is the concept Felice anticipated some minutes ago. He has experimented this type of joints in other projects for many years. And when he came to me with when he came to me and offered to use these joints in this work, well, I didn't hesitate. I think it's a great challenge. And it opens up to amazing, favorable scenarios and results. I think that the smooth joints ultimately reduce the concentration of forces. This is just my feeling. It makes me think of some other natural phenomena in airspace or water phenomena. So whenever you have you are exposed to short circuits, for example, from an hydraulic system point of view, well, this phenomena can be transferred to the world of structures too. And so smooth joints will deliver their benefits for sure. Pins, as you can see, are very specific, and they connect they connect the panels with the frame. They are slightly elongated, but they still have this swelling in their mid part, and they are thinner at the extremity. I apologize for going back to the past by comparing our work to major and great experiences from the past. I did this for two main reasons. First of all, because the use of timber alone in structures is something that we need to always be reminded of. It's part of history. We have experiences here with with wooden-made structures that to thousands of years ago. And not only that, for shelves, for example, there was the concept of prefabricated shelves made with these elements. So there is nothing new in the work we've carried out, but it is rather a highly sophisticated approach, which was also known in the past, and it allowed to work with modular elements that could be accurately repeated. Another important example we had in Europe is the one by Delors, Nouvelle Invention. He was able to build well at low cost, and Delors explained what his invention was about. That is to say, being able to use axes and beams jointed by pins, and the possibility to achieve major spaces of light. You can see this barrack, for example. Can you see all the light spaces that he was able to implement here? And in his treaty, he also wrote about a possible bridge on River Seine, which could potentially have at least 20 meters distance from with the various elements. Unfortunately, this piece of work was never actually built. The bridge was never built. We did carry out some experiments with our patent, and we realized that there are endless possibilities to implement complex shapes or forms, cylinders, cones, but also spheres or undetermined surfaces, as you can see at the bottom on the left. We were able to only virtually implement our patent in these elements, in a sphere, in a natural environment, up there on the right, as well as in the building industry, whereby we designed something similar to major works by important architects. So the BIM is a facilitated approach. BIM approach is facilitated, and it's an easier approach. It allows us to make 3D geometries, any type of geometry, and these geometries can be obtained immediately. You don't need a structural expert to use our shapes. In terms of modeling, it is just enough to have a clear mind on what shape, what form you want to have, and all the data related to it can be obtained. In terms of time frames, the planning is much easier with the BIM approach. Detailed construction simulation or detailed installation simulation is something that happens very swiftly, very quickly. And in addition to that, there is also an easy management system for the 6Ds. So this system can be made through the technique of assembling and disassembling. It's something that happens very easily because no glue and no adhesives are used. So the automation plant is already part of the system. So if frame is out of service, it's possible to replace it, provided that plants can be easily disconnected along the boundary or perimeter of the panel. made with our system is an assessment that tells us that we make large use of CNC machines. So worthwhile going forward with this type of system. Economic sustainability, like the frame plus one, must be compared with the economic sustainability of the other systems that are now available in the market. In mind also social and options. And I'd like to thank you for your attention.
Spera, voi avete assistito alla presentazione di un...
Thank you, Architect Spera. Just realization of a totally IDM project made with wood. So of course it's very complex. Read the full article that was published. Struttura Legno. If you can't find it, you can write to me, Sonia Maritan at gmail.com. And fourth speaker today, a wood disease expert, board member of the GQL board member, because wood is a live material. Being alive means it can have diseases. Gianfranco Magri, the headline here is the other side of the moon, potential threats to wood durability. So you have less than 15 minutes. Okay. So wood, before being processed, is perceived as something alive and then as something dead. However, wood is brought to second line by the industriousness and genius of man that creates stuff and makes it part of daily living and also of our history. So wood does have some frailties. It can be destroyed by fungi or by insects. Here we said circular lacrymans, so a fungus, and on the right the effect of an attack by terns. And this is so perfectly normal in nature. It's part of the biological life cycle. So, of course, we can accept what we see in the picture in nature, but we can accept it in manufacts made by man. It's like the moon. There's a dark side of the moon, the hidden side. Wood too does have a dark side, and this to people working with wood. And so the dark side is the attack of by woodworms. We also have the attacks by humidity, moistures, and this phenomena, it's not that these phenomena are not known as they are, but it's dynamics as well are known. But what is unknown is what to do in order to avoid that wood decays. So the concepts are prevention, care, and safety of wood in order to ensure its durability. Wood decay is not a static occurrence. It is a dynamic process that develops and unfolds along the whole wood supply chain. There is a critical element here along the entire supply chain of wood. On the left, you see the infestation process, so we can call a pervert process, because it concerns the works we want to preserve for the future. Our hands saying stop, and so we go back to the virtuous protection process. So people thinking about it develop a project, develop complementary competencies in order to transform these competencies into unity projects. All of the errors are made along the wood supply chain at any point, process point, do have an impact on on all future steps and phases. So what are the processes of the phases where we can have xylophagous infestations? I'm going to go very fast: cutting, storage, working, woodworking, user work, renovation, and maintenance. All of these phases can be attacked by xylophagous insects or fungi. So we have to know these. So wood-eating insects, wood-eaters. So what happens here in terms of decay of structural wood? So it's ill-projected spaces, not giving enough space to wood in order not to absorb water from the soil. It's formworks that are not removed. They are left there and they decay in contact with soil. They are attacked by woodworms, and then they attack the rest of the building. So building without covering or roof covering, so protection from weather elements. Then insufficiency or not enough leaning planes. So all those planes that where water can get stuck. Another error made in designing buildings, mostly in the past, but it was closing beams in counter ceilings without having some ventilation system. Beams do absorb moisture overnight and need to release it during the day. If they're locked up, it's like putting them in a sauna, and they get they rot very quickly. And then coating, so the paint which is used with a film that does not allow wood to breathe. So preventing natural phenomena and human errors to preserve wood. This is preventive conservation or preservation of wood. So preventive preservation at the state archives acts by coordinating diagnosis, care, safety measures, prevention, and monitoring. For all of the steps we've looked at, the supply chain, I mean, in every step in the supply chain, we can prevent wood decay. Of course, in order to do this, you need to be aware of the dynamics that are at play here. This is an example, the head of a rotten beam that was, and because there was no sufficient ventilation, there was no ventilation bed constructed here. This should make us think. This is a specific worm coming out of this door frame, and this specific insect attacks. I mean, it's very thin and does require some thickness. So the beams that were used to make these door frame were probably already infested when they were in the sawmill or when they were in the storage, in the warehouse. So We need to know the origins to be able to manage the present and to protect ourselves for the future, to avoid that the client ends up with an infestation of these insects at home. You need to be aware of your own role, and you have to have some professional ethics. This is Aristotle, to widen your vision. Okay, here, as we've seen before, is the true virtuous process, and it's the most evolved way for assuring wood durability. These are the first assessments, so preventive preservation. You can't trust the material you receive from a warehouse. It's too long an issue to discuss it here, but you can't trust. So to be on the safe side, structural beams must be disinfested so that all insects are eradicated before they are worked and used. On the first picture on the left here, you see cross infestation of different wooden items, furniture. So it doesn't make sense to treat the piano because it's valuable, because the whole environment is sick. You have to treat the whole environment, all of the wooden furniture and items here. The first treatment is thermoinduction, then infrared, microwaves, and then anoxia for some very delicate items like a violin, for instance. Preventive preservation, again, so it's important to make a diagnosis on infestants, moisture, risks and context, environment. And this has to be done by experts in the field. You can't do it yourself. Monitoring. Monitoring is important to control the state of infestation or the non-infestation after treatment, after disinfestation. This is also very important. On the left-hand side, you see beams jutting out of the perimeter wall, and this wood can be attacked on the outside by wood-eating insects, and it can achieve the inside of the wall, even though it is protected and has been treated, so below the surface. And to avoid this, you use injectors, nozzles, that allow you to force the treatment inside the beam, as you see on the right. So you create a mesh of 2 or 3 interceptors, really. These are barriers intercepting the insects. Monitoring is very important. Very quickly, UVA traps that you see on the left are traps to capture noble insects. Woodworms, specific woodworms, so anobide woodworms. They protect, UVAs protect also from the attack from the outside, and also protect adjacent rooms. Wherever it is not possible to capture these woodworms, you do some periodic monitoring on the holes. So this is retrofitting for safety. They allows you to protect, so it's a biodeterrent that protects wood from woodworms for 2 years, or there are nanotechnologies protecting wood for 20 years against wood-eating insects, humidity and ice, UV rays, and also oil repellent products. Then durability, what to do to maintain maintenance for maintaining wood durability. Clients don't know what to do. Who can explain it to them? Whoever designed the project and the house, it's an ecological duty. We're done. This is the the dress made by Menenia Agrippa to the people when they wanted to have equal rights. Then it was the first strike of history, and he said, as in all sets made by survive only if they work together. What does this mean outside of the metaphor? It means integrating research with a practical experience on the field, and it means coordinating the various disciplines into humanitarian protection projects. But you can be effective in protecting works, integrating different synergies, but that there are complementary synergies because they belong to the same project. Thank you, thank you, thank you. You've been able to close. You don't have any questions. You were great. All of our professors were very clear. So all of the surveyors, please do use wood, because you will give a real contribution to the future and to the future of our planet. Do you have a question? All right.
Così mi rovina se mi chiama bionda. Allora, noi...
All right, we are Istituto Belzoni of Padova High School with 3 classes here. Here we have 2 almost classes. We deal with wood technology, so this lecture was great for all of us, and we would like to thank you personally. And we would, on the other hand, we would also like to, and I think I'm speaking also on behalf of my colleagues, maybe creating synergies, working groups. Here we have a 4th class and a 5th grade, a 4th grade and 5th grade. So we start from the old techniques. We still explain all the very old techniques for using wooden pins, but so it's great because this is considered old technology, so it would be great to be able to use these old technologies in the future too. But I believe that your presentations have been the nicest, most beautiful thing we could assist in throughout the day. So maybe we can create some links or connections. So thank you to this teacher, professor, that gave us a hint of what we can do with wood and wood technology. And the floor. Enjoy the background, everybody.